Here I got a problem of finding derivative of 1 by x by first principle method. We have already discussed what is first principle method and what is definition by definition method, finding the derivative of different functions. Well, so suppose I have a function here, f of x equals to 1 by x, right? Actually f of x is actually y also. You can write y also, because I feel easy by taking y, because f of, when you put the like value of x in the function, you'll get the value of y coordinate you'll get. Well, so here y equals to 1 by x. Now how to find the derivative of this? Let me suppose, right, let delta x and delta y be the small change, be the small increment, or you can say change, small change in x and y. So therefore what I will get, I will get y plus delta y equals to 1 divided by x plus delta x, because there is small change in delta x also, that is why. And I think you know y delta x and y delta y I'm writing, right? Because in a function, any kind of curve you have, right? I hope this concept, you know, we have already discussed in the first introduction video of derivative, right? So here what I will do now, I'll just write here delta y equals to, now I will shift this y in right side, so I'll get 1 divided by x plus delta x minus minus y, simply I'm writing now. And next step, actually I can write 1 over x plus delta x minus, in the place of this y, right, what is y? It's 1 by x, so 1 over x. So now again delta y is going to equal with, now see, x plus delta x and x, so I can take the LCM of this, so I'll get x plus delta x times x, right? And when this x plus delta x will divide this whole quantity, I'll be left with x. So here will be x, and minus, when this x will divide this whole quantity, I'll get x plus delta x, so in the bracket x plus delta x. Now we can open the bracket, x minus delta x whole divided by x plus delta x times x. Now this x and x will cancel out, and I will be left with delta y equals to minus delta x whole divided by x plus delta x times x. Now, as usually we used to do, we need to divide left hand side as well as right hand side by the delta x. This is the process that we do in every problems, right, while finding out the derivative from the first principle. So let's divide both side, by delta x, right? I meant to say delta y divided by delta x equals to minus delta x whole divided by x plus delta x times x, and I need to divide this also by delta x, this side also, so 1 divided by delta x. So here also I divide by the delta x, here also I divide by the delta x, or you can say let's multiply both sides by 1 over delta x, right? I did it. And now, and taking limit, and we need to take limit also, taking limit as delta x tends to 0. So what I'm doing next thing, actually I'm taking limit also, so limit when delta x tends to 0, here also limit when delta x tends to 0. Now this actually delta x and delta x will cancel out, and I will be left with limit delta x tends to 0 equal with limit delta x tends to 0 minus 1 over x plus delta x times x. Now I can easily plug the value of delta x, there is no fear, right? So therefore limit, actually this is delta y over delta x. So now this quantity I can write derivative of the function y with respect to x is actually now minus 1 divided by x plus 0 times x, that's gonna be minus 1 over x square. So this is the derivative of the function f of x that we had taken here, right? Just right here. So what do we get? Derivative of the function is equals to minus 1 over x square, right? This is actually a little bit lengthy process, but definitely never you'll make any mistakes in this way. And one more shortest method we have, directly we can use the formula also, and that there will be no problem. That we can also say that it's also a first principle method. Here I did your whole process, I did, right? But that will be a shortcut by using the formula directly what we are getting by definition, what we are got, or by first principle. You can say by definition you can write here, or you can say by first principle. By first principle, my handwriting is, I think, the worst in the world. By first principle, um, derivative of the function f of x is actually equal with limit when h tends to 0. H is a small change in x, right? Here you can write delta x tends to h, like somewhere you might have seen delta x tends to 0. So there is no difference at all in writing anything. Whatever you want, you can write it, right? As I change it delta x, right? You can write delta h, like the h tends to 0 also, right? Well, I'm gonna do here delta x tends to 0 because this will give you more easiness, because here also I have increased delta x, right? Here I had increased delta x, so that's why here also I'm increasing delta x. Delta x tends to 0. This is actually formula, right? Derivative of the function, I need to find out f of x, so therefore now f of x plus h minus f of x, sorry, not the h, because is now f of x plus delta x minus f of x whole divided by delta x. Alright, so now limit when delta x tends to 0. Now f of x plus delta x. Now here in this function, f of function we have like x. When you put in this function x, you'll get 1 by x. So when you put here p, you'll get 1 by p. If you're putting here 1 apple, then you'll get 1 over 1 apple. So similarly, if you're putting here like x plus h, you'll get 1 over x plus h, right? So same thing, what I'll get here, you'll get 1 over x plus delta x, because I have a function actually f of x equals to 1 by x, and if I'm putting f of x plus delta x, so definitely what I should get out, I should get 1 over x plus delta x. So that is why I write here. And now similarly, if f of x, then we'll get 1 over x and then whole divided by delta x, and again limit delta x tends to 0, and this x will come this side and this whole quantity will come this side, so it will be x minus delta x whole divided by x plus delta x times x, and then this whole quantity divided by this delta x. Alright, and now see what is this, and this is cancelling out, and we are now left with limit delta x tends to 0 and minus delta x over now these things, these two things, right? We can put it down, these both things, so it will be x plus delta x times x and times this delta x, right? Now I can easily plug the value of limit, so I'll let me cut first this and then I'll plug the value. Alright, so delta x and delta x will cancel out, and I'm going to plug the value, so I'll get minus 1 x plus 0 times this x, that is actually finally minus 1 over x square. In this way also you can find out, both are the same ways, you know. By first principle directly you can use by using this formula also. Some people feel easy by doing formula, some people want to do everything, each and every step, right? So whatever you like you can do. Both are the first principle method, or you can say both are the definition methods. So I hope you understand this, and we'll be doing more problems, and now we are going to do a little bit complex, and in next video we'll be doing, I think, probably a sum rule related problem. Alright, so we'll meet in next video. Bye bye.